Hello, Algebra 2 students. Mrs. Myers here. Today we are going to do our first of two lessons on phase shift, which is another way of saying a horizontal shift. So what I have for you at the top of the paper here, yet again, once again I should say, is a reminder of what each of the two cycles looks like. Okay, so real quick, your sine cycle, okay, one full sine cycle, goes from a midline point to a max, to a midline point, to a min, and back to a midline point. Okay, keeping in mind that whatever your amplitude is, right, which is your vertical change between your midline and your max, has got to be exactly the same as your vertical change from your midline down to your min, okay, because those are both considered amplitudes. You want to make sure that that is scaled properly along your y-axis, okay, and that your critical points from your mid to your max to your mid, that they're all scaled equally along the x-axis as well. Now, what those max and min values are on the y-axis is going to be determined by your vertical dilation, that's your amplitude, okay? The radian measure that we have that scales out our x-axis here, and the radian measure that finishes our cycle, that's determined by your horizontal dilation, okay? That is your, what we call the period of the graph, all right? And we already talked about what a reflection does to a graph over the x-axis. Remember, that's the only reflection we're doing. That just basically interchanges your maximums and your minimums, makes the graph go upside down. We already talked about the vertical translation that moves the graph up and down. We're actually not going to put that in today's lesson, just to kind of, not make it be too much for today. And then we'll save that for next week. And then the other thing here to take a look at is what one cycle of cosine looks like. Okay, so that starts at a max, goes to a midline point, goes to a minimum, goes to a midline point, and back up to a max. And once again, make sure that you would have equal scaling along your y-axis determined by your vertical dilation. Make sure you have equal scaling along your x-axis determined by your horizontal dilation. Okay, so let's take a look at the phase shift. So we already know that we always do our transformations in the order of dilation, reflection, and translation, right? And so we're adding the last one here, the horizontal translation. How you know it's horizontal versus vertical is whether the operation is inside or outside your parent function, right? So let's take a look at doing a horizontal translation to your basic sine cycle, okay? So with your basic sine cycle here, we would have a max of 1 and a min of -1, right, for our parent graph. The cycle would end at 2 pi radians, right? It would take all the way around the unit circle to complete one cycle, okay? And that would mean that every interval, okay, there's 4 equal intervals that make up the cycle, would be pi over 2 radians. So it'd be 1 pi over 2, this would be 2 pi over 2 or pi radians, this would be 3 pi over 2, and then this would be 4 pi over 2, 4 pi over 2, or, 2 pi radians, okay? So if I asked you to make a sketch, okay, for y equals sine of x plus quantity pi over 2, right? That right there, see how this plus pi over 2 is inside the parent function? This is a horizontal translation. Okay, this is what we call our phase shift, the horizontal translation. Now, what you have to remember back from when we did transformations before is the horizontal translation is the opposite of what you would think, meaning that when we have this plus sign right here, when we have the addition of pi over 2 inside the parentheses, this is actually going to make your graph go to the left. So we write it as capital T, subscript negative pi over 2, 0. Okay, we're going to actually take this graph here and we're going to send it to the left pi over 2 radians. Okay, so really what's going to happen to our graph here, so I'm just going to make another sketch for us to look at. Okay. And we'll show what this graph looks like right beside it here, is every critical point is going to go pi over 2 radians to the left. So now what you need to make sure you look at is how many boxes have you let pi over 2 radians be equal to? Well, for me here, for this particular sketch, okay, pi over 2 radians was after one, critical point, and I decided to make that be 2 boxes. Of course, I did 2 more boxes to that critical point, 2 more boxes to that critical point, 2 more boxes to that critical point. Notice how that was equally scaled. So now when I want to move every point to the left pi over 2 radians, that's really just 2 boxes. So this would be negative pi over 2 radians, and that is actually where that cycle is going to start, right there with that critical point at negative pi over 2, 0. And then this critical point, which is the max, that's going to slide over here and actually be at 0, comma 1, okay? And then this midline point that was at pi radians, that's going to slide over here, and now be at pi over 2, comma 0. Okay, this minimum point that was at 3 pi over 2, negative 1, that's going to slide right over to there. So it's going to be at pi, comma, negative 1 down here. And then last but not least, this midline point that finishes the cycle, it's going to slide over there and be at 3 pi over 2 radians, comma 0. And then I just connect my points. Okay, and there you go. So that is what that graph looks like, right? It's just this one, but having moved to the left instead, okay? Now, if I had asked you to graph y equals sine of x minus pi over 2 instead, okay, all that would happen here is that you would get the graph going to the right pi over 2, okay, instead of to the left. So I'm going to actually save myself some room and sketch it right here. So that one's there, and I'll just come over here beside this. Okay, so basically that just means that this point right here is now going to actually slide over to there at pi over 2, comma 0, okay? Then the max is going to slide over to here at pi, comma 1, okay? Then this midline point right here is going to slide over to 3 pi over 2. Oh, I don't think I gave myself enough room, sugar. Okay, and then this minimum is going to slide over here to 2 pi, comma, negative 1. So we got there to there. And to there. All right, and I didn't give myself enough room. But anyways, you can see that the cycle would come back up here and it would finish at one more, okay, 2 more boxes further over, which would be at 5 pi over 2. Okay, and then that would be what that cycle would finish up. It just goes to the right as opposed to going to the left. All right, so that's just the basic idea of a phase shift. Now, I want to do a couple more examples, though, so we get some more transformations in there, though, but that's the basic idea of a phase shift. So let's take a look at this one to start with. We got y equals 5 sine of 2x plus pi over 2. Okay, now notice here that we've got a dilation of 5 to the y's, okay, to the y, okay, because it's outside, so this is going to change your amplitude. Okay, now this, okay, is going to change, see there's multiplication there, that is a dilation of 1/2 to the x's, so that's going to change your period. So instead of your period being a standard 2 pi, it's going to be 2 pi times 1/2, which means it's going to be pi radians, and that's going to make your scale be pi divided by 4, right? But then there's something else, okay? Then we've got this plus pi over 2. Now, very, very tricky. Pay careful attention here, okay? This is not your phase shift, okay? This is not your phase shift because you've had a dilation go on, okay? This expression right here has to be in what we call factored form. You have to always note your phase shift when you've got your x with a coefficient of 1, okay, inside a set of parentheses like this. So what we're going to do is we're going to factor out that 2, okay, and when we factor out the 2, you see how 2 times x, we're going to factor out the 2, then what's left in that set of parentheses there, that's going to be our phase shift, okay? So 2 times what would get you pi over 2? Well, that would be pi over 4, right? So if you do 2 times pi over 4, right, that would get you to pi over 2. Now I can see that my phase shift is pi over 4 radians, but not to the right, because remember, phase shift is always the opposite direction, to the left. It's negative pi over 4, comma 0. All right, so let's take a look at our sketching here, okay? So we know that we are going to go to the left, so I want to position my y-axis a little bit further right, because otherwise I won't have enough room to actually do my phase shifting. Okay, but what I'm going to do though first is I'm going to make my sketch without doing the phase shift. Okay, I always like to make my sketch first just doing the dilations. Okay, so I know for the sine cycle, okay, that I am going to go from my midline point first up to a maximum. Now the max is 5. I mean, I really didn't give myself enough room to go up 5 boxes and down 5 boxes, and I'm really not even doing a vertical translation, so it doesn't matter. So I'm just going to go 2 boxes and call that 5, okay, and 2 boxes, call that -5. What I'm also going to do is I'm going to stick with doing 2 boxes to get to the next critical point, which is a max. You could just do 1 box if you'd like, it doesn't matter. All right, and then I'm going to go 2 more boxes to get to my midline point, right? So, midline to max, back to midline, and then 2 more boxes later will get me to the minimum, right? And then 2 more boxes later will get me to the midline, okay? So here's my sine cycle, okay? I'm going, again, I know that my max and my min are at 5 and -5 because that was my amplitude, and that was my vertical dilation. Now what I'm going to do, I'm going to look at my horizontal dilation. Remember, I've scaled this by factor 1/2, which means I've compressed it down, which means my period is not 2 pi radians for like the parent graph, it's only pi radians. And then there's 4 equal intervals that makes up that cycle. So again, I divided pi by 4. So now I know every pi over 4 radians, I get another critical point. So 1 pi over 4, this is 2 pi over 4. You can write that as pi over 2 if you'd like. That's 3 pi over 4, and then that would be 4 pi over 4, or pi, right? Okay, so this is what my sketch looks like with just the dilations, but I'm not done. I still have to do that phase shift. Okay, I'm going to do that horizontal shift. So what I want to do is I want to look at where that radian measure is on my scale so that I know how many boxes I'm going to move my graph to the left. Remember, I'm going to move it to the left. So pi over 4 radians, that's only 1 critical point worth. Okay, it's only 1/4 of the cycle is what I'm phase shifting, and I decide to let that be 2 boxes. So that means that this would be -pi over 4, and that point is just going to move over here. Okay, and then this point just moves over here. Okay, this point moves over to there. This point moves over to there. This point moves over there. And then I just connect those points. Okay, and then remember, you can do this in color. If you do it lightly enough, okay, then you could just go ahead and erase, for example. I mean, I know I said you can kind of just cross it out, but depending on how many transformations you're doing, it might look a little bit sloppy if you do that. So, if you're just using pencil, like you should be for homeworks anyways, then you just erase that, okay? So now that's what that cycle looks like, all finished, right? This is your final graph. Okay, let's do one more, and with this next one that we're going to do, let's have it be for the cosine cycle, okay? So we want to make sure that we get some practice in with that too. So let's have y equals -3, so hopefully you know what that negative is all about, cosine of 3x minus pi. All right, so before we even start sketching, let's just take a look at our transformations. So we know that this multiplication by 3 is going to be a vertical dilation, scale factor 3. So this is going to change my amplitude, right? It's now going to be 3. This multiplication by 3 right here, that's inside though, so that's going to affect my x's. And remember, you always got to reciprocate that, so that's 1/3. And that's going to change your period. So 2 pi times 1/3. So now my period is 2 pi over 3. So what does that mean about my scale, right? So you always take your period and divide it by 4, which means you take your period and multiply it by 1/4, and then that reduces to pi over 6. Okay, so that is my scale. Now I'm not done, okay? I am going to make my initial sketch based on just my dilations, but what else do I do after that? So you see this negative right here, okay? That is outside the function, okay? So that is a vertical reflection, meaning over the x-axis. Okay, I'll do that after I've done my dilations. And last but not least, okay, so now I've got this subtraction of pi, but it's inside the set of parentheses, so I know it's horizontal. Well, remember what I just said up here. This is not your phase shift. You can only indicate what your phase shift is when x has a coefficient of 1. So because x had a coefficient of 2 here, I'd have factored out first. Then I was able to see what my phase shift is. So now I've got to factor out the 3, okay? And what I'm left with, that's your phase shift. So when you factor out 3 from pi, you're left with pi over 3. Okay, so because 3 times pi over 3 would get you back to pi. So now I know that my phase shift is pi over 3. But which direction are you going to go in? Okay, well, because this is a subtraction, I'm going to go to the right, pi over 3. Okay, so now I can actually put my y-axis as far left as I'd like. because I'm going to move my graph to the right. Oh, sorry, I'm not getting my x-axis drawn very neatly here. Try to fix that. It's not always that easy to hold the phone to video and write at the same time. Okay, so anyway, I'm going to give myself a +3 and a -3 scaling on my y-axis because I know I'm going to have that vertical dilation, and so I might as well just go up 3 boxes and down 3 boxes for my amplitude of 3. And I am going to give myself 4 equal intervals. Again, I'm just going to keep with the theme of today and do every 2 boxes. Okay, but for cosine, I start at a max. So I go max, okay, then I go midline, and I go minimum, midline, maximum. Okay, and now I got to put a scaling here. Okay, so you can't just do that when not put a scaling. You got to put a scaling because how else am I going to know how to do my phase shift, right? So how we put a scaling on the x-axis is we look at our period. Okay, this tells us where the cycle ends. Okay, this tells us that it now took 2π/3 radians to complete the cycle. Because why? I horizontally dilated by a scale factor of 1/3, right? I compressed my cycle down from its original 2π radians. That would be the parent graph. Okay, I compressed it down, and now it only takes 2π/3 radians. But what are these radian measures for each critical point? See, if you don't know what those radian measures are, how are you going to phase shift your graph? So I took here's my phase shift, okay? So what I do is I take my period, and I divide it by 4. So when you take 2π/3 and you divide it by 4, which means you multiply by 1/4, you get π/6. So this is 1π/6. This is then 2π/6, right? This is 3π/6, and then this is 4π/6. So notice 4π/6 reduces. You could certainly reduce this down to π/2. You could certainly reduce this down to π/3. And that's important to realize that it reduces down because now, okay, well, actually, I'm going to do the reflection first, but you're going to be phase shifting π/3 radians, so we need to know what that means, okay? All right, let's do the reflection next, okay? It's always dilations, then reflection, then translation. So make your initial sketch for the dilation first, then if you have a reflection, do that. Then if you have translations, do that, okay? And remember, we're going to save the vertical translation for our next lesson. Okay, I'm not putting that in here now, just that we don't have 2 different translations going on at the same time. But we'll do that next week. All right, so reflect over the x-axis. Okay, that's easy. That just basically interchanges your max and your mins, right? It just makes the graph go upside down. So max goes down to minimum. This midline stays here. Minimum now goes up to a maximum. Midline stays there. Maximum goes down to a minimum. Okay, so there is your cycle, okay? And again, you can just, maybe use color here to do this, or you can kind of cross it out, or if you do it lightly enough, you could do like me, and you could just erase it. Okay, so now I'm ready to do the last transformation, okay, for this problem, and that is to phase shift it π/3 radians to the right. So what is π/3 radians? Okay, again, that's right here. See, that reduces down to π/3 radians, right? So this point goes here now, okay? That's 4 boxes worth to get to π/3, okay? This point goes over here. This point goes over here, okay? That point goes there, and that point goes there. All right, so now I go like this, 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 and this. And what you might have even realized is I actually just traced over what the original cycle looked like. So isn't that interesting how basically a couple different sequences of transformations kind of brings us right back to what the original graph looked like anyway. Okay, so that's really interesting the way that happens, right? So anyways, let's erase this graph here. That way we are looking at our final product. Okay, now, by the way, if the directions tell you to sketch 2 cycles, then what you would need to do is you would need to continue this. Okay, you can continue it off to the right, or you can continue it off to the left. Now, actually, since we originally had it done, I could, for example, go, all right, well, let me just continue this to here. Let me just continue this to here, right? And then what would come next is going down to the midline. Okay, but that wouldn't be the end. Of course, I don't have enough room to do this. Okay, but that wouldn't be the end. Okay, because after you come up here, then you'd have to go all the way down to the minimum. And there you'd go. It's a little sloppy because I'm trying to hold the camera and do this at the same time, but there you go. Okay, so now that would be 2 cycles with all those transformations done in there. All right, so we got another day of practicing transformations ahead of us. On Thursday, where we add in the vertical translation, but hopefully you understood this okay. Okay, let me know if you have any difficulties with the homework, and I could try to help you if you send me, like an email or a remind message or something like that. All right, hope all is well. Bye.